Hello, everyone. Tonight, we are tracing a riddle older than birds, stranger than dragons, and fluffier than you ever imagined. Picture this: that the jungle around you buzzes ferns, towering humidity clinging to your neck like an anxious ghost. You shuffle forward half awake toward a rock split down the middle. Inside it, a fossilized creature with claws, teeth, and feathers. Yes, feathers, not wings, not flight. Just tufts of primitive fluff clinging to bone like static cling to socks. Welcome to a time when birds didn't exist, but their fashion sense already did. So, before you get comfortable, take a moment to like the video and subscribe, but only if you really like what I do here. And tell me where you're tuning in from and what time it is. I want to know which one of us is most dangerously close to 3-ish a.m. Now, turn off the lights, maybe turn on the fan for some soothing noise, and let's get started tonight. You're walking through the dusty corridor of a museum alone, except for the motion sensors that blink red as you pass. You stop in front of a glass case where a slab of stone sits cracked open like a fortune cookie. Inside, something both familiar and alien stares back. It's not quite bird, not quite lizard. A bony tail juts out behind it, claws curve forward, and stretched across its skeleton are feathery impressions like a child drew a chicken with a pencil and forgot to erase the dinosaur underneath. This is Sinosauropteryx, and it's the start of your trouble. See, for decades, paleontologists insisted dinosaurs were scaly, cold-blooded monsters, nothing like birds. But then China cracked open its sedimentary treasure chest and outspilled these odd little theropods with filaments, not scales. These weren't modern feathers yet, but fuzzy hair-like structures called proto-feathers. They clung to the skin like frayed yarn, wrapping the tail and spine in a halo of ancient insulation. You probably wouldn't want to cuddle one, but it sure wasn't naked. Scientists were cautious at first. After all, fossil impressions can be misleading. Was this fluff just collagen breakdown? A freak mineral deposit? But sample after sample began showing the same thing: tiny repeating structures outside the bones. And not just any structures. They resembled pennaceous formations, central shafts, barbs, branching filaments. It was like finding a duck in a trench coat pretending to be a dragon. One of the biggest surprises came with Dilong, a small tyrannosaur relative. Yes, that's right. Tyrannosaur. The name usually brings to mind a roaring, scaly beast with arms too short to pick up its own dignity. But Dilong was fluffy. It sported downy proto-feathers along its back and tail. Suddenly, the idea that feathers were exclusive to avian lines melted like an ice cube in Cretaceous heat. And here's where things get real fuzzy in every sense. Paleontologists started suspecting feathers weren't just a late-game innovation before the bird transition. They might have appeared way earlier, like over 200 million years ago earlier. That's Triassic territory. That's we barely figured out legs territory. It begs the question, why? Why would a creature that couldn't fly wear feathers? Thermoregulation was the early guess. Feathers, after all, are excellent insulators. If these early theropods were endothermic, or at least trying to be a fuzzy coat, would have helped them keep warm during cool desert nights or high-latitude shifts. Imagine shivering in a canyon while a feathered friend curls up and quietly judges your lack of evolution. But then came the kicker. Some of these proto-feathered species lived in warm, even tropical areas, not exactly wool sweater weather. That's when researchers started whispering the other F-word display. You know, the prehistoric equivalent of hair dye and leather jackets. Flashy feathers could signal health status or mating readiness. A Cretaceous Tinder profile in living color. Oddly enough, it turns out that not all feathers are created equal. Some were simple filaments. Others had branching barbs, pigment sacs, or iridescent gleams when viewed under special light. Even before birds took to the skies, nature was out here inventing high fashion, and dinosaurs were walking the runway. probably with more grace than any of us when we stub a toe in the dark. A strange fossil from Russia nicknamed Kulindodromeus added more fuel to the fire. It wasn't a meat-eating theropod, but a small plant eater. And yet, it had feathery structures too. That means feather-like coverings might not have evolved just once or only in meat eaters. They may have been ancestral present in the common ancestor of all dinosaurs. If true, it's like discovering your grumpy great-uncle was once a fabulous ballroom dancer. Of course, not everyone agrees. Historians still debate whether Kulindodromeus's fuzz was truly feather-like or more akin to mammalian hair. Others think feathers may have evolved multiple times independently. Either way, it's clear we've only plucked the surface of this mystery. Here's the wildest twist yet. Some fossils preserve not just feather impressions, but color. Thanks to melanosome's microscopic pigment carriers, scientists can now estimate the original hues of these ancient animals. And let me tell you, they weren't drab. Think rusty reds, smoky grays, maybe even vibrant patterns. Your typical dinosaur might have looked more like a rebellious tropical bird than a Jurassic horror show. In one case, scientists discovered banded tails alternating stripes like a raccoon's. On another, they found iridescent feather traces similar to modern hummingbirds. Nature doesn't do boring, not even in the Mesozoic. And just when you thought things couldn't get more uncomfortable, here's an odd fact for your nightmares. Feathers are made of keratin, the same stuff as your fingernails. So every time a dino molted, it was essentially exfoliating 1,000 ancient nail clippings into the wind. You're standing in the dark now, just outside the fossil chamber, and the air feels thicker, heavier. Maybe it's the realization that you've always pictured dinosaurs wrong. Maybe it's the image of a baby Sinosauropteryx fluffing up like a damp chick under the prehistoric sun. Or maybe it's just the creepy janitor watching you from the other hallway. Either way, one thing is certain, this story is only beginning. You take a few slow steps through the museum's dim emergency lights, passing exhibit labels that haven't been updated since the 90s. There, in faded print, you read the phrase that once defined an entire era of paleontology: dinosaurs were cold-blooded reptiles. It's a little like finding an old medical book that recommends leeches for headaches, charming in its ignorance but wildly outdated. Back when this idea took root, scientists believed dinosaurs were just oversized cousins of modern lizards. Scaly, slow sunbathing monsters with blood as sluggish as molasses in a freezer. They imagined T-Rex dragging its tail like a reluctant toddler, warming itself in the sun before lurching into motion. It all seemed tidy, logical even. But the fossils had other plans. You crouch beside a display of coelophysis bones, light, hollow, delicate, like a ballet dancer's skeleton. Not exactly what you'd expect from a lumbering cold-blood. Early paleontologists had already noticed this weird bird-like trait, but shrugged it off. Birds, after all, weren't even part of the Dino Club back then. They were seen as separate, a side project of evolution, not a legacy. Then came the smoking gun bone histology. Slide under a microscope with me for a moment. That's your eyes squinting through the lens, and there, stained purple and brown, you see lines inside fossilized bone. Growth rings. In cold-blooded animals like crocodiles, these rings are widely spaced, indicating slow seasonal growth. But many theropods, their rings are packed tightly, just like those of warm-blooded mammals and birds. Rapid growth, high metabolism, hot blood pumping like a caffeinated drummer. That's not just science, it's a betrayal of decades of dinosaur assumptions. You pull back from the microscope and your worldview is officially fried. Still, not everyone was ready to let go of the lizard fantasy. Cold-blooded made sense for such big animals, didn't it? After all, elephants don't need to sprint, and size alone helps maintain body temperature through something called gigantothermy. A real word that sounds like it was invented by a sleep-deprived physicist. But that theory hit a snag. Many feathered dinos weren't big at all. Microraptor, for instance, was about the size of a house cat. if your house cat had 4 wings and an attitude problem. At that size, being cold-blooded would have been a death sentence without a warm rock and a dream. Enter proto-feathers, insulation baby. If these animals were generating internal heat even partially, they needed a way to trap it. That's what feathers do, and that's what scaly reptiles don't. Thermal imaging simulations. Yes, they exist, have taken dino models, wrapped them in virtual feathers, and shown how much more effectively they retain heat, especially around the chest and underarms where the major blood vessels ran. Basically, dinosaurs needed feathered sweaters before it was cool. But feathers weren't the only clues. You trace your finger over a fossil trackway. It's not just the bones that matter, it's how the animals moved. These prints show quick, balanced steps, narrow gaits, and occasionally, just occasionally, drag marks from something brushing the ground. Not a tail. Feathers. Think of a broom made of hair gliding behind a predator in the twilight. Some trackways even show what look like resting positions. Limbs tucked in, torso settled down. Not unlike how birds sit to rest. A scaly reptile sprawls. A warm-blooded, light-boned creature crouches. This debate, cold-blooded versus warm-blooded, still simmers. Historians and paleontologists argue across cafeteria tables and international conferences. Some suggest a middle path mesothermy. That's where the animal generates its own heat, but not as efficiently as modern birds or mammals. Think Komodo dragons, but turbocharged. And here's where it gets juicy. Some modern reptiles can generate short bursts of internal heat during activity. Pythons, for example, can raise their body temperature during egg incubation by shivering. Shivering. Like your grandma in church. If that doesn't make you question every nature documentary you've ever watched, I don't know what will. Let's take a break for an odd fact. Did you know chickens, modern birds, direct dinosaur descendants can remember over 100 faces? That includes humans, other chickens, and apparently one scientist's ex-wife. Dinosaurs might not have had the emotional depth of a golden retriever, but they likely weren't brain-dead monsters either. That heat-regulating system needed fuel, and that meant brains and behavior sharper than the public ever gave them credit for. Back to those cold-blooded theories, some researchers still dig in their heels. They point to crocodilians, the dinosaurs' distant cousins who remain scaly, slow, and largely unchanged. But even crocodiles aren't entirely cold-blooded. In fact, some species show bursts of surprising speed and endurance, and crocodile hearts. 4 chambers, just like birds, just like us. So what's the truth? Were dinosaurs warm-blooded? The real answer is it's complicated. Paleontologists lean toward yes for many theropods, especially the smaller, more bird-like ones. Larger species may have operated on a hybrid system. The deeper you dig, the more nuance you find. It's like trying to solve a murder mystery in a world where the suspects all went extinct and the fingerprints were left in volcanic ash. You press your forehead to the cool glass of a feathered dinosaur model. It's sleek, sharp-eyed, like a hawk crossed with a murder robot. There's nothing slow or lizard-like here. This is a creature with a pulse, with heat rising off its body into a cold morning wind, eyes scanning the horizon for movement. You blink, and for a moment it almost feels like it's looking back. Whatever else they were, dinosaurs weren't static. They were dynamic, diverse, and adapted for a world that demanded innovation. Feathers. They weren't an afterthought. They were part of that equation from early on. You step back into the corridor where the lights flicker and the air hums like a low growl. Maybe the ancient world wasn't so different from our own after all, just faster, fiercer, and covered in more fluff than we dared imagine. It doesn't fly. It doesn't even have wings, not real ones. What it does have is feathers everywhere. Filaments sprouting from its arms, neck, spine, and tail puffed like a feather boa at a Cretaceous costume party. And here's the kicker, it can't fly at all. You crouch low and watch it scurry. This isn't a mistake of nature, It's a clue. You see, feathers didn't start with flight. That's one of those backwards human assumptions like thinking spoons were invented to eat soup, and not just to stir boiling tar while yelling incantations. The earliest feathers didn't help dinosaurs soar, they helped them survive in other ways entirely. Imagine proto-feathers as the Swiss Army knife of the Mesozoic world. First, they offered insulation. Like we said, fluffy dinosaurs were probably regulating their internal heat and keeping the kids warm too. But that's just the start. Some researchers now believe the first feathers evolved as sensory tools, much like a cat's whiskers or your own awful bedhead when it tells you which direction you roll during the night. These filamentous structures, soft and unbarbed, might have helped creatures detect changes in the air, wind direction, nearby movement, even social cues. Others see the beginnings of feathers as camouflage, breaking up outlines, mimicking foliage, or blending into volcanic ash fields. A sneaky way to not get eaten or to sneak up and do the eating. Either way effective. And then came display. You know the type. Flashy, arrogant, probably had a favorite tree stump it stood on to be noticed. Scientists believe certain feather patterns or pigments could have been used in courtship or territorial disputes. Picture two early theropods fluffing themselves like deranged parrots during a mating season standoff, while a confused proto-mammal watches and slowly backs into a burrow. Here's the thing that really fries your circuits. Feather evolution predates flight by tens of millions of years. You're looking at least 50 million years of fluff before any real flapping happened. That's like humans inventing hats 10,000 years before realizing they could also be used as frisbees. Take Enchiornis, for instance, a small crow-sized dinosaur found with an explosion of feathers on its arms, legs, and tail. It even had color patterns black and white with hints of red on the crown. Very punk rock. It had wings. It had feathers. But it couldn't fly properly. Glide maybe. Crash stylishly into a tree. Likely. Microraptor takes it up a notch. 4 wings. That's right, wings on the arms and legs. It probably glided from tree to tree like a prehistoric flying squirrel with eyeliner. Did it evolve feathers to fly? Not originally. But eventually some clever species figured out that flapping those fluffy appendages could do more than impress the ladies. It could cheat gravity, and that's where things take off. Literally. Feathers became more complex over time. From simple filaments to compound structures with barbs and vein alignment, nature began to refine the tool. But not for fun, for function. Glide turned into flap and flap turned into controlled flight. The bone structures adapted. Sternums strengthened. Clavicles fused into wishbones. Yes, that thing you break for luck at Thanksgiving started as a flight stabilizer. Now, here's the debate that still makes paleontologists sweat: was flight a ground-up adaptation or tree down? Did dinosaurs start by running and jumping into the air like flightless turkeys on a caffeine high? Or did they begin by gliding from tree branches, slowly building muscle and coordination over generations? Historians still argue this one. Both camps have good points. The tree-down camp points to creatures like Microraptor that clearly adapted for gliding. The ground-up crew says some theropods had wing-flapping behaviors for balance and display while running, maybe even to scare prey or shield nests from wind. Over time, that flapping grew efficient enough to lift them off the ground. Either way, the result was flight. But the cause? That started with fluff. Here's an odd little fact to confuse you further. Some insects have evolved wing-like structures without being able to fly. It's for mating display or temperature regulation. So even across kingdoms, nature just loves fluffing things up for reasons that have nothing to do with soaring through the sky. But don't picture feathers as a straight-line invention. Evolution isn't a checklist. It's a chaotic art project. Some dinosaurs gained feathers, some lost them. Some grew them only on their arms, others only on their tails, and some wore full-body coats like they were trying out for Broadway. Even flighted birds today aren't the end of that road. Ostriches can't fly, chickens barely, penguins underwater only. But they've kept the feathers. Why? Because those multi-purpose tools still work for display, for warmth, for comfort, for memory. Yes, some birds remember each other's feather patterns the way you remember a weird haircut from middle school. You look back at the dinosaur you saw earlier. It's perched now on a rock, preening, pulling old filaments through its beak, snout, and letting loose a soft coo. Not a roar, not a hiss, just a coo. And suddenly it feels very familiar. Not like a monster, like a pigeon with ambition. The trail leads you deeper into the forest. Branches scrape at your arms like ghost hands, and the humidity presses against your skin, but you're not afraid. Not really. You understand now. Feathers weren't an accident. They were an early gift used not for flying, but for surviving in a world where only the weirdest ideas lasted long enough to make history. And the weirdest part of all, they worked. You wake up in a clearing, probably figuratively, but it feels real. The prehistoric forest hums around you, full of unseen creatures whispering and rustling ferns and dripping moss. And there, just a few feet away, he's doing it again. He struts like he owns the underbrush. Feathers puffed up in every direction, tail lifted, head bobbing, throat inflating just enough to flash a patch of fiery orange. He turns his side to the sunlight, the angles of his proto-feathers catching golden rays. Somewhere nearby, another creature, smaller, sleeker, most definitely female, is watching. And honestly, so are you. You've just walked into the original fashion show where courtship and color mattered long before the first bird ever took wing. That puffed-up fella, he's probably an early oviraptorosaur or a tiny dromaeosaurid, think Protarchaeopteryx or Caudipteryx. He's not just showing off because he likes how the feathers feel. He's advertising health status, genetics, and attitude. The Mesozoic dating scene wasn't subtle. You see, once feathers existed, they were too useful to keep simple. At first, they insulated, then they started displaying colors. Eventually, those colors began carrying meaning. Not just, I'm warm, but I'm strong. I'm fertile. I'm not the one you want to fight today. And in the world of visual signaling, nothing beats a fan of shimmering plumes backed by a swagger that says, I dare you to ignore me. This is where evolutionary biology gets flirty. In many species, sexual selection shapes traits more powerfully than environmental pressure. It's how peacocks ended up looking like exploding disco balls. The same might be true for many feathered dinosaurs. Scientists analyzing fossilized melanosomes in feathers have found not only patterns but pigments, reds, blacks, browns, even possible hints of iridescence. That's a word that means shiny and mysterious, and also very likely to attract mates while being utterly impractical for camouflage. And here's where the debate really flares up. Historians still argue whether the primary force behind early feather development was thermoregulation or display. Both make sense. Both have fossil support. But when you see fossils with symmetrical decorative feather fans, feathers too big or too ornate to be functional, you start to suspect a prehistoric version of peacocking. Feathers evolved before flight. Sure, but they didn't wait around to be useful. They adapted to the social structure of their time. And that included romance, rivalry, and reputation. Let's talk about the Mesozoic version of Tinder. Courtship displays probably varied wildly by species. In some, it might have involved head bobbing and vocalizations. Others may have danced, puffed out their throats, or rustled tail fans. Some might have even changed color slightly based on blood flow, like a turkey's face when it's excited, or your uncle during Thanksgiving dinner when politics come up. And these behaviors weren't reserved for males. Fossil evidence suggests that in some species, both sexes had feather ornamentation. That tells us courtship might have been more collaborative or competitive than we thought. Odd fact time, there's a bird today called the superb lyrebird that can imitate chainsaws. That's right. To attract mates, it mimics the most terrifying sound in the modern forest. If that's what sexual selection produces in our time, imagine the chaos it unleashed in the Cretaceous. Maybe one dino tried to sound like a falling tree. Maybe another just hissed louder than its neighbors. Behavior doesn't fossilize, unfortunately. We're stuck with bones and the occasional miracle preservation of feathers and pigment, but even that tells a surprisingly clear story display mattered. A lot. Take Epidexipteryx, for instance. No flight feathers, no aerodynamic shape, but four long ribbon-like tail feathers, decorative, useless for gliding, entirely likely to get caught on every passing branch. Evolution doesn't make ornaments like that unless they serve a social purpose. And this social world was probably richer than we imagined. Groups might have displayed together. Flocks may have formed display arenas. Young males might have practiced in circles while older females judged like disapproving dance moms. And somewhere in that mix, new generations were selected not just for strength but for style. There's a term in evolutionary biology called the runaway selection hypothesis. It means that once a trait is preferred even arbitrarily, natural selection can favor it into absurdity. Think deer antlers so big they prevent the animal from walking through a forest. Now apply that to feathers. Maybe some poor dino evolved tail feathers so vast and colorful they glowed in the moonlight, but also made him very, very easy to spot for predators. Love is stupid like that. That's the dangerous side of being fabulous. Still, courtship wasn't all color and fluff. Some fossil sites show paired nests, communal brooding areas, and signs of repeated visitation. These creatures weren't just strutting, they were bonding, building, maybe even parenting. And if feathers help them attract mates, they may also have helped them keep those mates raise offspring and survive in tight-knit groups. Think of it as prehistoric PTA meetings, but with more feathers and fewer cupcakes. Display in the end was a gamble. It paid off when it led to mating success, but it also cost energy, resources, and safety. Only those strong enough to carry the weight of flamboyance could survive. And so, over millions of years, feathers weren't just selected, they were refined into the dazzling, shimmering, utterly unnecessary beauty we see in birds today. You step back from the clearing. The strutting male has vanished into the brush, maybe having impressed his mate, maybe having scared off a rival. And as the leaves settle, the forest feels quieter, more personal. Like you've just watched a drama unfold that's been playing on loop for 100 million years. And the best part? It's still happening on rooftops in forests, at petting zoos, and on every pigeon doing its weird head bob strut near the subway. Feathers weren't just nature's tool. They were its love letter, and they were writing it long before anything ever took to the skies. You feel like you're being followed. Not in a horror movie, way more like that eerie sense you get when a very tiny, very judgmental predator is watching you from the bushes. Something fast, something with feathers. You turn slowly, and there it is. About the size of a turkey, but with eyes that look like they know algebra, and claws that look like they don't need to. Its tail feathers quiver as it tilts its head. Then it darts off light as a leaf in the wind. Congratulations! You have just seen Deinonychus, and it's nothing like the ones in those old dinosaur movies. These were the tiny tyrants of their day, not the towering monsters of pop culture, but sleek, agile hunters decked out in feathers and fury. And the best part, their fearsome reputation didn't come from sheer size or brute strength. It came from coordination, intelligence, and style. And feathers were absolutely part of the package. Let's rewind. When Deinonychus was first described in the 1960s, it flipped the whole idea of what a dinosaur could be. It wasn't slow. It wasn't dumb. It wasn't scaly. It was a swift, warm-blooded predator with a sickle-shaped toe claw and the kind of build that screamed bird more than lizard. This was the dino that sparked the dinosaur renaissance the moment paleontologists started rethinking everything. Feathers were discovered later. At first, there were just impressions, fine hair-like filaments and fossils of close relatives. Then full-on feathers on other dromaeosaurs. And eventually, even tiny quill knobs, those bumps on the bone where feathers anchor in Velociraptor. Suddenly, it was clear these tiny killers weren't wearing scales. They were wrapped in fluff. That changes everything. Feathers in this context weren't for flight. Deinonychus couldn't fly, not even close. But the feathers still mattered. They may have helped with balance, like a dynamic tail stabilizer during high-speed chases. They may have served for display for insulation, or even to shield eggs in a nest. And in pack scenarios, they may have been used to communicate flaring fluffing, signaling intent like bird signals in a traffic jam. And yes, pack hunting. That's the hypothesis that just won't die. Fossil sites show multiple individuals found near large prey. Does it mean they hunted together? Maybe. Some scientists suggest cooperative hunting behaviors like wolves or lions. Others argue they were just opportunists who gathered around a kill like freeloaders at a buffet. Historians still debate whether these were true packs or just accidental party crashers. But there's no question these feathered raptors had brains bigger than their body size would suggest. Enlarged brain cases, keen senses, and limbs that imply agility and coordination. You probably wouldn't want to meet one in a dark alley. Or a bright meadow, honestly. Odd fact. These guys probably made sounds. No, not roars, get that out of your head. Think more like birds' hisses, clicks, maybe even primitive calls. Some researchers believe they communicated with each other using body posture and vocalizations feathered drama queens in a deadly ballet. Now picture this, you're crouching behind a log, watching a group of them fan out around a small herbivore. One circles left feathers raised like hackles. Another flashes its tail, distracting the prey. And the third, it darts and claws, flashing feathers, rustling like a warning whispered on silk. It's like watching a performance designed to end in blood. But also respect the fluff, because it wasn't just armor, it was an evolutionary toolkit. Feathers helped regulate temperature. That much is clear. But in something like Deinonychus, they also helped refine movement. Think of wing-assisted running, where young birds today flap their wings to help them run up steep inclines. This wing-assisted incline running, or weir, if you want to impress someone at a party, could have played a role in how these predators chased, climbed, or jumped. Which brings us to trees. Were these little raptors climbers? Some think so. Their claws' agility and feather arrangement hint at arboreal behavior. It's possible they used trees to ambush prey, escape larger predators, or just show off their fancy plumage. There's even a theory that some of these early raptors glided, not flew, but glided from tree to tree. That alone puts them dangerously close to the evolutionary threshold for flight. That line between predator and bird isn't a chasm, it's a blur. Feathers weren't a sign of weakness. They were the mark of innovation, of animals that weren't content to be cold-blooded tanks. These were nimble, expressive, clever creatures that dressed for the job they wanted, whether that was to be the terror of the underbrush or the ancestor of songbirds. And speaking of birds, just glance sideways at a crow next time. That little glint in its eye, that's a Deinonychus whispering through time. You might think it's overkill to imagine something so deadly wrapped in something so soft. But that's the point. The Mesozoic didn't care about our expectations. It mixed teeth and feathers, fury and fluff with zero concern for how it would look on a movie poster. You step away from the forest edge, heart still racing. The tiny tyrant has vanished. Maybe it's up a tree. Maybe it's behind you. Maybe it's gone to join its descendants in the nearest city park disguised as a murder of crows. You'll never look at birds the same way again. You open your eyes to the soft shimmer of dawn light cutting through mist, and for a moment, it looks like the air itself is glowing. Then you realize it's not the air. It's the creature stepping out of the ferns, about the size of a large chicken. Maybe slightly bigger but sleeker. Its feathers seem to catch the light in strange ways, rippling with subtle shades of green-blue, even violet like someone painted a crow with oil. It tilts its head and turns just so, and for a flash it's brilliant. Almost too brilliant. You squint. Did that thing just sparkle? Yes, it did. Welcome to the world of dinosaur shimmer. You see, feathers aren't just soft little heat traps. They're canvas. And in the late Jurassic to early Cretaceous nature had started painting with light. All thanks to microscopic structures called melanosomes. These tiny pigment-carrying organelles are what give feathers their color in birds today, and they're what allow us to peer backward into the past and see just how fabulous dinosaurs might have been. When paleontologists first began scanning fossil feathers under electron microscopes, they weren't expecting much. But then they saw patterns, rows of melanosomes, so well preserved you'd think the animal had just molted last week. The shape, size, and arrangement of these melanosomes told an astonishing story. The feathers weren't just dull and brown. They had color. Microraptor, that little four-winged acrobat, is now believed to have been black with a hint of iridescence like a grackle in sunlight. Others, like Anchiornis, showed a mixture of gray body feathers, a red crest, and white highlights on the wings. That's not camouflage, that's a billboard. It wasn't long before scientists realized these ancient creatures weren't dressing for survival alone. They were using color, vivid, startling, intentional color, for communication, for identification, and maybe for drama. Iridescence, in particular, is a tricky adaptation. It doesn't come from pigment, but from structure layers of keratin and melanosomes that reflect light in complex ways. That means natural selection had to favor incredibly specific and delicate feather arrangements. And all this happened before the invention of flight. So here's the mystery. Why did nature go through all the trouble of evolving iridescent feathers in animals that couldn't even get airborne? The answer might be simple: they were seen. In a world teeming with sharp-eyed predators and potential mates, being seen and being recognized could mean the difference between life and death, or at least between offspring and obscurity. If your feathers shimmered in a certain way under morning light, your mate might pick you over a duller rival. If your iridescent patches marked you as a threat, a challenger might back down. And if your color pattern matched the local terrain just right, you might live to scurry another day. Historians still debate whether color evolved before iridescence or alongside it. The fossil record is frustratingly incomplete, and pigment doesn't always fossilize the same way in every environment. Some species might have been brightly colored, with simple hues: reds from carotenoids, blacks from melanin. Others developed iridescence as a side effect of strengthening feathers. Either way, once those traits appeared, they stuck around. Here's your offbeat fact for the night. Hummingbirds aren't iridescent because they're magical, though it feels like it. Their feathers contain layers so fine and intricate that they bend light like tiny prisms. Change your viewing angle, and their colors change too. We suspect Microraptor did the same thing, so depending on how the sunlight hit it, it could go from jet black to deep blue to invisible in a blink. Imagine hunting that in a forest. But there's a catch. Iridescence isn't perfect. It works best in dappled light, not in harsh sun or darkness. That suggests these creatures lived in specific habitats: dense forests, shaded canopies, places where light filtered through in patches like a natural disco ball. So now you're imagining early feathered dinosaurs not as open plain stalkers, but as forest creatures. Darting through leaves, skimming across branches, flashes of color revealing rank mood, maybe even emotion. A whole visual language painted in structure and shimmer. Some species, like Cynornithosaurus, have been reconstructed with color gradients across the body, dark on top, pale beneath. That's called counter-shading, and it helps break up the body's outline. It's still used by animals today, from sharks to deer to, you guessed it, birds. And here's a fun connection. Modern birds use their colors not just for mating and hiding, but for social hierarchy. In some species, brighter feathers signal dominance. In others, duller colors indicate submissiveness. There's no reason to think dinosaurs couldn't have developed similar systems. Suddenly, feathers aren't just insulation or display. They're identity, social status, emotional broadcast, maybe even something close to culture. You lean against a tree and close your eyes. The idea that these ancient animals had such visual complexity makes everything feel different. Less monstrous, more familiar. You start thinking about peacocks, parrots, magpies, all flaunting their colors for reasons that feel human. And you wonder if that same instinct, this drive to decorate, to signal to shine, started long before our species ever dreamed of art. Which brings us back to the glowing creature you saw earlier. It's gone now, vanished into the brush. But its shimmer lingers in your mind like an afterimage. Not just a dinosaur, but a beacon. A sign that life has always found ways to be seen, even when no one was watching yet. And so you walk on deeper into the forest where shadows twist and light flickers through leaves, like it's searching for something. Maybe another shimmer, maybe a clue, maybe a reason. One thing's clear in the ancient world: survival wasn't just about teeth and claws. It was about how well you could shine. You're crouching now. The ground is cold, cooler than you'd expect for the Cretaceous, and soft with ash and decaying plant matter. But your focus isn't on the earth. It's on a fossil just ahead, curled into a tight pose, head tucked, forelimbs splayed over a clutch of oval eggs. You've seen skeletons before, but this one feels alive, protective, tender. You're looking at a brooding dinosaur. The feathers are faint in the stone, but they're there, light traces like brushstrokes fanning across the arms, draping over the nest like a prehistoric blanket. You don't need to imagine why. You can feel it. This wasn't just instinct, it was care. And this, perhaps more than anything else, is where feathers change the game. In modern birds, brooding is everything. A parent often both sits on the eggs to keep them warm, turning them periodically, shielding them from wind and rain. That's only possible with insulation. Without feathers, warmth seeps away. Life never gets its chance. So now imagine a small theropod, something like Psittacipodi, a close cousin of Oviraptor. Feathers spreading across its chest and arms, forming a makeshift incubator. It perches on its eggs not to crush them, but to keep them alive. And the fossil record agrees. We've found skeletons frozen in exactly that pose, arms out, knees bent, tail wrapped around. Still waiting. This was a different kind of dinosaur, a parent. And if feathers helped make that possible, well, who needs flight? You've already won the evolutionary lottery if your offspring live long enough to carry your genes forward. Feathers weren't just for the flashy, they were for the devoted. Of course, parenting isn't unique to feathered dinosaurs. Crocodiles guard their nests. Some fish mouth brood. But the style of brooding we see here, sitting atop eggs with body heat, using arms and feathers to shield, perhaps even to signal other members of the group, is eerily bird-like, or rather the other way around. Historians still debate whether these behaviors evolved once or multiple times. Did brooding originate with one common ancestor? Or did it emerge in parallel among various feathered species? The fossil evidence is tantalizing but frustratingly incomplete. What we do know is that brooding required more than behavior. It required biology: feathers to trap heat, lightweight bones to sit delicately, and the instincts to stay day after day. And brooding wasn't just physical. Some of these feathered dinosaurs may have used vocalizations or feather displays to ward off predators or communicate with mates. There's even speculation that they may have recognized their own eggs by color or texture, just like birds today do. That's not just survival, that's awareness. Time for your odd fact: some modern birds can control the temperature of each egg in a clutch independently by adjusting how they sit. That's like having a built-in thermostat for every baby. If their ancestors could do anything even remotely similar, then we're talking about parenting skills far more advanced than we've ever credited to reptiles. You walk past the fossil slowly respectful now. This isn't just a skeleton, it's a snapshot of life in progress, a creature that paused its world to nurture another's. And it did so using the softest tool evolution had provided: feathers. Of course, there's always more. Think beyond brooding. Feathers could have lined nests, cushioning eggs and helping regulate moisture. They might have been plucked and arranged like modern birds do, both for comfort and for temperature control. And when the hatchlings arrived, those same feathers may have kept the parents warm enough to feed and guard them through the dangerous early weeks. Fossils have even captured impressions of tiny, newly hatched dinosaurs with filament-like fuzz suggesting they were born with some form of downy covering. They weren't helpless worms, they were fluffy, ready to scurry, ready to hide beneath mom's plumage. You stop, listen. Imagine the soft chirps of babies calling out in the brush, not reptiles hissing, but high-pitched squeaky calls like ducklings or chicks. And imagine the adult replying not with a roar, but with a ruffling of feathers, a gentle nudge, a positioning of the body to shield them from wind. You're not in a land of monsters anymore. You're in a cradle. This shift, this idea that dinosaurs might have nurtured their young, cared for them, even communicated with them, was a radical concept once. It still feels that way sometimes. Because we've been conditioned to see dinosaurs as brutal, scaly engines of destruction. But the more we learn, the softer they become. Not weaker, just more real. And feathers were at the heart of that transformation. Back to City Pati for a moment. Its name means funeral pyre lord because of the dramatic pose its fossil was found in, arms stretched deathless, defiant. But that pose, it's exactly the kind of position a bird takes to warm its eggs. A guardian pose. A sacrificial one. It may have died in a sandstorm or under sudden volcanic ash, but it died doing something birds still do today. You brush your hand over a replica of the fossil gently. It's hard not to be moved. This isn't ancient violence. This is ancient tenderness, and it changes you. Because in this moment you understand feathers weren't just about flight or fashion. They were about function, about warmth, about connection, about passing life forward when the odds were stacked against it. And in a world that could bury you in ash or swallow you in teeth. What better armor was there than love, heat, and a little fluff? You walk into a darker room now, colder, dustier, with glass cases that haven't been cleaned since someone decided fax machines were the future. Fossils line the walls. Some are missing labels. Some have the wrong ones. But all of them share one thing in common: confusion. This is the Hall of Misfits, the Room of Mistakes, the fossil record's blooper reel. You stop at one display in particular. It's a slab of stone, pristine, except for the unmistakable outline of a creature that seems half bird, half lizard, and completely suspicious. One wing's too long, the tail's too stiff, and the posture looks like it was drawn by someone who'd never seen a living thing. The placard reads Archaeoraptor, and below that, scratched out with marker, retracted. Ah yes, the infamous Archaeoraptor hoax. This fossil was once paraded as the missing link between dinosaurs and birds, a masterpiece of evolutionary evidence. It was on magazine covers and documentaries in heated scientific debates. Until, of course, it turned out to be a Frankenstein's monster half-bird, half-dinosaur, and all glued together by an ambitious fossil dealer hoping to make a quick buck. The head belonged to a primitive bird, the tail to a small dromaeosaur. Stuck together, they made evolutionary magic until scientists saw through the seams. You shake your head. It's hard not to laugh a little, but also hard not to sigh. Because this is what science sometimes looks like. Messy, eager, a little gullible, but always willing to correct itself. And behind the fakes, the reconstructions, the well-meaning guesses, there's something far more important: persistence. You see, for decades, feathered dinosaurs weren't even allowed to exist. The narrative was set: dinosaurs were reptiles. Reptiles didn't have feathers and birds came later. To suggest otherwise was career suicide. But as the evidence mounted from real fossils, not haphazard glue jobs, that narrative began to crack. Archaeopteryx was one of the earliest troublemakers. Discovered in 1861, this Jurassic creature had both flight feathers and claws teeth, and a long tail. It was a beautiful mess, and scientists didn't know what to do with it. Bird reptile. Something in between. For over a century, it remained an evolutionary enigma until the discovery of Anchiornis, Microraptor, Sinosauropteryx, and others began filling in the gaps. But not without resistance. Historians still debate how to classify these early flyers and their feathery cousins. Some clung to the idea that birds evolved beside dinosaurs, not from them. Others argued over the placement of the feathered fossils. Were they really dinosaurs? Or something birdier? The lines were blurry, and the fossil record kept misbehaving. In some cases, fossils were labeled incorrectly for decades. A feathery fossil discovered in the 1980s was initially thought to be a primitive bird, but later reclassified as a non-avian theropod. Another was shelved in a drawer for 20 years before someone finally noticed the faint impression of proto-feathers surrounding its bones. And then there are the ones we still don't fully understand. Creatures with feather tufts in odd places on elbows, tails, ankles. Or species with asymmetrical wing feathers but no flight capabilities. They don't fit the tidy evolutionary ladder we'd prefer. They zigzag through time like a child's drawing of a family tree during a sugar crash. But that's nature for you. It rarely builds a straight line. Evolution is more like jazz, messy, improvisational, full of detours and weird solos that somehow make sense in the end. Take Scansoriopteryx, for example. A tiny tree-climbing dinosaur with elongated fingers and bizarre feathers. For years, scientists debated whether it was a bird, a dinosaur, or some kind of missing elf. Its anatomy didn't fit cleanly into any one group. And yet, there it was. Real, complicated, annoyingly inconsistent. Odd fact. One of the most well-preserved feathered fossils was originally discovered by a farmer in Liaoning Province, China, who used it as a kitchen tile. That's right. He was frying eggs on top of the very proof that dinosaurs had feathers. Sometimes the biggest evolutionary revelations are found under yesterday's stir-fry. You keep moving through the gallery, the air thick with the scent of dust and missed opportunities. So many fossils, so many wrong guesses, and yet every one of them mattered. Even the fakes, even the mislabeled. They sparked discussion, reevaluation, new digs, better science. Archaeoraptor was a lie, but it pushed researchers to look harder. It led to deeper scans, more careful excavation, and eventually the real evidence that would prove feathered dinosaurs weren't just possible, they were common. Paleontology is patient. It forgives its own mistakes. Eventually, you stop in front of a newer display, one that wasn't here the last time you visited. It's a juvenile Utyrannus, a distant cousin of T-Rex covered in thick woolly feathers. No glue, no Photoshop, just bone and truth. A 30-foot predator wrapped in fluff like it was preparing for a snowstorm. And you smile, because this is where the story starts to make sense again. Feathers weren't just for the small, the delicate, the bird-like. They were for the bold, the powerful, the misunderstood. And as science gets better, the lies fall away and the fluff remains. The fossil record is not a perfect diary. It's a field notebook stained and tattered, full of scribbles and guesses and crossed-out pages. But if you read between the lines, you start to see a pattern. A story. A feathered, fractured history that's slowly being pieced back together. And you're part of it now. You're outside now, feet crunching over gravel as a sparrow hops across the path in front of you. It flutters up into a nearby bush tail, twitching head tilted. You watch it for a moment, its sleek feathers, the way it flicks its wings, the bright black bead of its eye. Harmless, right? Wrong. You're looking at a dinosaur. No, not like a dinosaur, not descended from one, a real one, a living, breathing, feathered dinosaur. Because birds aren't just the closest relatives to dinosaurs, they are dinosaurs. The last ones standing. The final branch of a tree that once held giants. You've probably heard the phrase before, birds are living dinosaurs. But it's not a metaphor, it's not poetic, it's biological fact. When you trace the evolutionary lineage from modern birds back through time, through Archaeopteryx, Anchiornis velociraptor, all the way to the earliest theropods, there's no break, no gap, no moment when one stops and the other begins. It's just feathers all the way down. Back in the early 2000s, paleontologists were still cautious. The idea of birds as dinosaurs had traction, but skeptics remained. Then the discoveries from Liaoning started piling up feathered clawed-toothed creatures in exquisite preservation. Some perched, some running, some with plumage so detailed it looked like you could ruffle it. Even better. Some of them had wishbones, hollow bones, air sacs, nesting behaviors, eggshell structures identical to birds. At a certain point, the weight of the evidence tipped the scale so hard it snapped the old narrative in half. Historians still debate the exact moment of divergence, the point where non-avian dinosaurs became avian ones. Was it Archaeopteryx too early, some say? Maybe it was Confucius ornis, with its toothless beak and long tail feathers. Or perhaps it was a species we haven't even found yet, a transitional ghost waiting in stone somewhere in Mongolia or Madagascar. But the labels don't matter. The reality does. Birds aren't separate from dinosaurs. They're what happens when dinosaurs survive. Here's an odd fact to really bake your brain. Chickens have more in common with T-Rex than they do with crocodiles. Despite appearances, crocodiles are more distantly related. It's the birds that inherited the structure, the wishbone, the bipedal posture, the eggshell chemistry. And yes, even the feathers. Genetic studies back it up. Scientists have isolated proteins from T-Rex fossils and compared them to living animals. The closest match birds, not reptiles. Birds. At the molecular level, your lunch might be related to the king of the late Cretaceous. Try not to think about that next time you order nuggets. But this isn't just about bones and genes. It's about behavior. You watch a crow hide its food for later using tools and solving puzzles. You see a heron stalk fish with surgical precision. You witness a rooster puff up to guard his hens. These aren't lizards. These are clever, complex, emotional creatures descended from a world that once roared. Even pigeons, those urban velociraptors, have been trained to recognize faces, symbols, even abstract concepts. Somewhere in that feathery little brain is a whisper of the ancient world, and it's still learning. Of course, birds don't all act like dinosaurs. Some have lost their claws, some have evolved beaks, others can no longer fly. Penguins turned their wings into flippers. Kiwis hid their wings entirely. And then there are cassowaries, giant, flightless, helmet-headed birds that look like they walked straight out of the Cretaceous and didn't appreciate being disturbed. Cassowaries are a special case. Their bones, posture, and even their toes resemble raptors. They can jump, kick, and when threatened, they don't run. They charge. They've even been known to disembowel predators with a single strike. Cute, but even the tiny birds are fierce. Hummingbirds, those delicate nectar sippers, are aggressively territorial. They'll dive bomb anything that gets too close. They hum not just from wing speed, but from sheer irritation. And all of it. The fluff, the fight, the flight, it's dinosaur DNA at work. You pause now at the edge of a pond. A duck glides by, trailed by 6 fuzzy ducklings. They follow instinctively, peeping and paddling. And suddenly you remember that brooding fossil from before. You remember the feathers, the protective stance, the clutch of eggs. This isn't a new behavior. This is old, ancient, a continuation of survival techniques that have been tested across asteroid impacts, volcanic winters, and mass extinctions. Dinosaurs didn't vanish. The giant ones did. The rest adapted. Flight wasn't just a new tool, it was an escape hatch. The sky was open. The forests offered cover. Feathers already useful became critical. Small, fast, insulated animals had the edge. And when the dust settled, those were the ones still chirping. It's poetic in a weird way. The creatures that once ruled the earth with teeth and claws left behind descendants that rule the air with song. You glance up. A hawk circles overhead motionless against the clouds, and you feel it now not as a symbol but as a link. That's not a bird of prey. That's a dinosaur with altitude. You brush aside a low-hanging branch and find yourself staring at something unexpected. A hadrosaur, beaked, big-bellied. A gentle herbivore chewing quietly beneath a canopy of cycads. Nothing threatening about it, no claws, no teeth, no chase. But something's off. You narrow your eyes. It's the tufts. Small plumes of filament-like feathers peek from its elbows, find maybe even its hips, not showy, not bird-like, just there. Decorative, functional, accidental. And with that, your whole idea of who gets to wear feathers starts unraveling. Feathers, it turns out, didn't belong only to the swift or the sleek. They weren't exclusive to predators or flyers. Evidence now suggests that even some herbivorous dinosaurs, those big lumbering plant eaters, we always imagined as naked-skinned or scaly, may have worn feathers too, or at least proto-feathers. And it changes everything. Take Culindrodromeus, small bipedal plant eating and not a theropod. Its fossil was discovered in Siberia, preserved so well that scientists could see not just its bones but its skin, and that skin bore complex filaments. 3 different types of them, in fact. Some were simple, others branched. One kind even formed scale-like patches across the limbs, as though the dinosaur couldn't decide what aesthetic it was going for. Culindrodromeus belonged to a group of dinosaurs not previously associated with feathers at all. That means feathers may have evolved earlier than we thought, perhaps all the way back to the common ancestor of all dinosaurs. Not just the bird-like ones, all of them. Historians still debate whether this was a case of shared ancestry or convergent evolution. Did feathers arise once and get passed down widely, or did they evolve multiple times in unrelated lineages? The fossil record is coy. Some species show no evidence of feathers while others do, but preservation biases make it hard to be sure. Here's the twist: some dinosaurs had both feathers and scales. On different body parts. Feathers on the spine or limbs, scales on the tail or snout. Just like modern birds really look at a chicken's scaly legs and feathery body. Or better yet, a pigeon's neck shimmer and scaly toes. They're dinosaurs in a mixed outfit. So what's the function of feathers on an herbivore? It certainly wasn't flight. Probably not display either, not the kind that draws attention anyway. Instead, those feathers may have offered insulation. Culindrodromeus lived in a cooler climate than many other dinosaurs, so extra warmth makes sense. Or maybe those tufts were sensory, like cat whiskers or porcupine quills. Some may even have helped deter parasites or wick moisture from the skin. Odd fact. Some mammals today, like elephants, have sparse body hair that helps with heat regulation by cooling. The individual hairs create microcurrents that increase airflow and evaporation. Feathers used lightly might have done the same. So maybe your sleepy hadrosaur isn't trying to make a fashion statement. Maybe it's just beating the heat, or the cold, or both depending on the time of day. And if herbivores had feathers, that raises another eyebrow. What about sauropods, the long-necked giants of the Mesozoic Apatosaurus? Diplodocus titanosaurs. They're not usually pictured with fluff, but imagine for a moment a baby sauropod, just hatched, still vulnerable body heat, hard to maintain. Would a layer of fuzzy down help it survive the night chill? Possibly. We haven't yet found definitive proof of feathers in sauropods, but no one's ruling it out either. And if they did have feathers even briefly as hatchlings, it would suggest a far more widespread evolutionary strategy than we thought. A trait used not just for flight, but for life at every stage. You move through the underbrush, brushing past ferns as tall as you are, and hear a rustle. Something big, but not fast. A herd of ornithopods grazes ahead, tails, swaying feather tufts lifting in the wind like flags. The effect is subtle but surreal. It looks like grassland birds crossed with cows. And you start to realize maybe this wasn't weird at all. Feathers didn't make dinosaurs strange. They made them normal. If anything, the scaly naked monsters we grew up with were the real outliers. The invention of feathers may have been so early, so basic that most dinosaurs had some form of them, whether elaborate or humble. It's just that scales fossilize better. Easier to preserve, easier to imagine, but not necessarily accurate. Which brings us back to modern birds. Because even today there's an incredible variety in feather types and placement. Some birds have naked necks, some grow elaborate head crests, others develop single tufts for no clear reason. If that level of variety exists now, why wouldn't it have existed? Then dinosaurs with all their forms and niches probably explored every combination of fluff and skin and color that nature could imagine. And the more we discover, the less surprised we'll be. Somewhere in a dig site, still untouched, a fossil waits an armored dinosaur with soft patches under the tail. Or a ceratopsian with quills along its frill. Or maybe even a stegosaur with filamentous tufts where its plates meet the spine. The past isn't done whispering secrets, not by a long shot. You take one last look at the hadrosaur. Its tail flicks its eyes, blinks slowly, and it goes back to chewing. The wind ripples through the trees, catching those odd little feathered tufts again. Not much, but enough. Enough to make you wonder how many other quiet creatures wore their fluff with quiet pride, never for show, just because it worked. You blink through dust and sun as the landscape changes around you. Gone are the dense forests and swampy basins. You're standing now on cracked earth in a dry, open expanse where the wind never seems to stop. Sand skitters across the ground in tiny whirls. Somewhere something chirps. A desert, yes, but not lifeless. In the distance you see a silhouette move. Not skulking or sprinting, but posing. Arms out, tail arched, feathers rippling along its spine, and head flaring slightly like sails in a breeze. You watch transfixed as another creature approaches. It answers the pose with its own smaller, tighter, more aggressive. The two freeze their feather crests trembling like dueling flags. This isn't a fight, it's a performance. You've walked into a prehistoric catwalk, a place where feathers weren't just insulation or camouflage, but a language of posture pattern and pride. Display behavior. Scientists have talked about it for decades in birds. It's how peacocks win mates, how turkeys assert dominance, how birds of paradise pull off dance routines so bizarre they'd make TikTok jealous. But the idea that dinosaurs might have done the same, that's only recently stopped being laughed out of paleontology seminars. And now we're starting to take it seriously. Let's talk about desert dinosaurs. Those that lived in hot, dry, open landscapes where visual signaling mattered. In these open habitats, you can't rely on ambush. You have to be seen. You have to advertise. Not just to potential mates, but to rivals, predators, and your own kin. That's where feathers come in. Not fluffy coats, but crests, quills, fans. Structures too elaborate to serve any survival function, unless survival includes winning hearts and deterring bullies. Look at Corythoraptor. A recently discovered oviraptorosaur from China, it had a tall, hollow cassowary-like crest on its head. Combine that with a probable feather covering, and you've got a dino that looked like it was wearing a helmet made of bone and disco. Then there's Bapiosaurus, with long, ribbon-like feathers extending from its arms, not for flying, not for warming, but very likely for strutting. In life, those feathers might have caught sunlight and cast shadows, creating ripple effects, like a moving mirage. Historians still debate whether desert feather structures were for species recognition or mating display. Some fossils suggest highly individualized plumage, meaning no two dinosaurs looked quite the same. Others imply sexual dimorphism, where males and females had different feather shapes or colors. Odd fact, even today in some bird species, only juveniles display certain feathers. They grow them during adolescence, use them briefly, and molt them as adults. If similar cycles existed in feathered dinosaurs, then entire parts of their appearance may have been seasonal, tied to age mating cycles or dominance hierarchies. The problem is, we're guessing at the context. Fossils don't preserve sound behavior or bright color unless we're lucky with melanosomes. So we reconstruct poses based on bone articulation and educated guesses. But those guesses are getting better. New scanning technologies and digital modeling let researchers simulate feather placement and movement under different conditions, sunlight angles, wind speeds, even group interactions. And in those simulations, one thing keeps standing out: feathered crests and fans work best in open spaces. That's why this desert scene matters. Because for all the talk of dense jungles and brooding nests, some feathered dinosaurs lived in dusty basins and arid plains. Places where heat shimmered, shadows mattered, and standing out or blending in was a game of life and death. Or sometimes just romance. And it's not just head crests. Some dinosaurs had tail fans like caudipteryx, which sported symmetrical feathers arranged around the tail tip, likely used for display. When you wag a feathered tail at someone in the animal kingdom, you're not saying hello. You're saying pay attention. But here's a deeper angle. What if feathers in deserts weren't just about attraction? What if they played a role in thermoregulation too? Some modern birds in hot climates use feathers to reflect sunlight, creating microclimates around their bodies. Pale, loose feathers bounce heat. Dark, dense ones trap it. Dinosaurs could have used their feathers the same way, especially if their color patterns varied by region or season. In fact, some desert-living birds have feathery panting fans near the throat, which help dissipate heat during rest. It's not hard to imagine feathered theropods evolving similar structures, ornate, yes, but practical too. Evolution loves a good multitasker. And then there's group dynamics. In open habitats, animals often evolve display behaviors for social cohesion. Look at flamingos or cranes. Their synchronized displays help bond flocks, reinforce hierarchies, or signal migration readiness. If feathered dinosaurs like oviraptorosaurs lived in groups, and some nesting sites suggest they did, then display might have kept them together. You picture it now, a line of desert dinosaurs moving together, feathers rustling in the hot wind, the crests on their heads swaying with each step like banners. The younger ones mimic the elders, the rivals posture from a distance. No roars, just rhythm, motion, color, communication without a single sound. And you realize feathers didn't just give dinosaurs warmth or lift, they gave them presence. In a world where survival depended not just on strength but on signals, feathers were how you got noticed and how you stayed remembered. As the desert sun lowers, your display pair finally disengages. One flicks its tail and turns away. The other lowers its crest and settles onto a rock. No blood, no chase. Just a conversation and posture, answered and concluded. And the wind moves on. You're standing now on foreign soil. Not metaphorically, literally. Welcome to Liaoning Province, China. Cold winters, warm summers, quiet villages, and some of the most explosive fossil discoveries of the last 100 years buried in its slate-colored stone. Not dinosaur bones alone, no. You're in the motherlode of feathered dinosaurs. And it didn't happen by accident. It started with farmers. You bend down, brush away some imaginary dust, and look at the slab in front of you. A creature lies within, preserved in eerie perfection. Arms splayed, tail feathered. Even the skin between its claws looks intact. This isn't a skeleton. It's a snapshot. A fossil so detailed it might as well be a death photograph. Back in the 1990s, local farmers in Liaoning began turning up fossils in their fields. Not just bones, but whole animals preserved in fine volcanic ash that hardened into shale. The conditions had been perfect. A volcanic eruption, a lake bed, a sudden burial. The kind of freak preservation event that science usually dreams about. Except this time it kept happening. Soon, truckloads of fossils began leaving the villages. Some sold to collectors, others to scientists. A few were altered, fused together, or enhanced with extra bones to raise their value. It was messy, confusing, but buried in that chaos was a new vision of the Mesozoic. And the stars of the show, feathered dinosaurs, dozens of them. Microraptor with its four-winged body and tail fan like a dart. Sonornithosaurus, light-boned and sleek. Anchiornis, whose feathers showed color patterns still visible after millions of years. Every few months brought another shock. A raptor with iridescent feathers. A bird-like dinosaur with teeth. A non-avian species with a beak. Liaoning didn't just rewrite dinosaur evolution. It shoved the old books into a paper shredder and mailed the confetti to museums around the world. The fossils here were so detailed that paleontologists could see muscle impressions, crop contents, even parasite marks. And of course, feathers. Not imaginary ones, or wishful reconstructions, real ones, fossilized with veins, barbs, shafts. Preserved so well you can almost feel the texture with your eyes. Historians still debate whether all these animals were part of the same environment, or if the fossil beds layered different time periods. Some argue that floods and storms transported carcasses from miles away. Others believe these dinosaurs lived and died right here in a thriving ecosystem where feathered creatures ruled both branches and ground. Odd fact. A few of the Liaoning fossils show preserved melanosomes. Yes, those pigment sacs again so clearly that scientists match their shape and density to those in modern birds. That's how they knew Anchiornis had a rusty red head and black and white wings. Nature had painted in layers and time left the outlines intact. And then there's the firecrackers. You laugh quietly remembering the story. When the fossils started drawing international attention, smugglers got clever. To disguise the sound of chiseling stone, they began working at night and covering the noise with fireworks used for celebrations, yes, but also for fossil theft. At one point, illegal fossil trading rivaled drug trafficking in the region. Fossils moved from muddy markets to prestigious auction houses faster than authorities could react. But not all stories were shady. Some of the most significant finds came from local farmers who partnered with scientists. They shared knowledge, helped excavate, protected sites from theft. In one village, a farmer even turned his home into a museum because people here understood what they were sitting on. Not just rock, not just relics, but a window into a forgotten world where dinosaurs preened, perched, glided, and maybe even cawed in the twilight. You walk between exhibits now. It's not a museum, but a lineup of fossil slabs leaned against walls, some labeled, some not. Eutyrannus, the giant fluffy tyrannosaur. Genuine long, with arm feathers like eagle wings and a snarl you wouldn't want to meet at eye level. Each one a contradiction of what you thought dinosaurs could be. They weren't all flyers, or even gliders. Many had feathers and lived entirely on the ground. Some had long feathers on the arms but stubby tails. Others were built like chickens with the temper of wolves. And every time you think you figured them out, a new Liaoning fossil says, not quite. This region, quiet, cold, remote, has become one of the loudest voices in paleontology. Because here, science met serendipity. Volcanic ash turned to stone. Curious farmers became fossil hunters. And the feathered truth of the Mesozoic clawed its way out of the ground, fluffy and undeniable. The most beautiful part. These fossils don't just tell us about dinosaurs, They tell us about the transition, the period where wings were optional, where teeth still lingered in beaks, where claws still curled at the tips of feathered arms. It's not a hard cutoff. It's a blurred line full of hybrids, experiments, and evolutionary whisper. You pause at one final slab. The creature within is juvenile. Its feathers aren't fully grown, the bones aren't hardened, and yet it's preserved as clearly as if it died yesterday. Maybe it tripped. Maybe it fell into ash and never got up. But whatever happened, it left a message, one that scientists, students, and curious wanderers like you are still reading. Feathers weren't rare. They weren't exotic. They were normal. And here, under the gray skies of Liaoning, they speak louder than any roar. You're walking past a movie poster now, one of those glossy, oversized sheets taped to a theater wall. There he is, center frame Velociraptor. Scaly, lethal, 2 meters tall, eyes like a hawk, fingers curled, no feathers in sight. You remember this version. You probably grew up with him. Maybe had a toy, maybe tried the pose. But here's the thing, they got it wrong. You duck behind the poster into another world. One with facts, not CGI, and the real Velociraptor mongoliensis about the size of a turkey. Feathered. Sharp, yes, but not a scaly monster from Hollywood nightmares. More like a bird that could kill you with alarming precision. The truth is scarier in its subtlety. You've probably heard the corrections before. Velociraptor was feathered. Jurassic Park used the wrong species. Technically, that was closer to Deinonychus. And yes, all of that's true. But we need to dig deeper, because Velociraptor, the real one, is more fascinating than fiction ever allowed. First, the fossils don't lie. In 2007, paleontologists discovered quill knobs, those telltale bumps along the forearm bones where flight feathers anchor in a Velociraptor specimen. That wasn't speculation. That was evidence. Bone deep. Confirmed. Feathers. On the arms, possibly on the tail. Maybe even covering parts of the torso. Not flight feathers, mind you. Velociraptor couldn't fly. But the structure of the arms, the arrangement of bones, and those knobs tell a clear story. They were inherited from ancestors that had flight or at least gliding capability. So why keep the feathers? Historians still debate the reason. Some argue they were vestigial, slowly fading through generations like wisdom teeth or your ability to sleep without lower back pain. Others believe they still served a function, display thermoregulation protection for nesting young. Or maybe they helped in hunting, used to balance, distract, or corral prey. Odd fact, some modern birds use their wings in combat. Wing-assisted kicks, feather flashes, even short jabs. Could Velociraptor have done the same? The fossil doesn't scream martial arts, but the idea is gaining traction. The rest of Velociraptor's body tells its own story. A long, stiff tail for balance. A curved claw on each foot, razor-sharp and likely used for pinning prey. Forward-facing eyes. A relatively large brain. And jaws full of serrated teeth. Not huge, not indestructible, but smart, fast, coordinated, and feathered. The problem isn't just with the movie design, it's with what the design left out. When you strip the feathers, you strip the nuance. You lose the bird-like intelligence, the social complexity, the warmth, literal and emotional. Feathers imply temperature regulation. They imply parenting. They imply a creature more alive than lizard-like. But you get it. The 90s weren't ready for a killer chicken. Now, though, we are. You sit in a small exhibit room with a life-sized model of the real Velociraptor. It's smaller than you expect, about knee height. Sleek, covered in dark, matte feathers. The arms flare outward, slightly balancing as it turns its head towards you. It looks like it's waiting for you to move first, like it's calculating odds. And suddenly, the feathers make it more intimidating. This isn't a roaring brute, it's an assassin, a ghost, a silent strike with eyes that see the world in ultraviolet and limbs made to pivot mid-air. Feathers don't soften it, they sharpen it. You remember a fossil found in Mongolia velociraptor locked in combat with a protoceratops. The two died mid-battle preserved in sand claws embedded in flesh. It's known as the fighting dinosaurs fossil. A snapshot of raw survival. And guess what? The velociraptor in that fossil almost certainly had feathers. Let that sink in. Hollywood gave us monsters, nature gave us athletes, and modern birds still carry that DNA. You've seen it in hawks, in roadrunners, in owls so quiet they sound like ghosts on approach. The spirit of Velociraptor didn't die. It perched, it adapted, and it hunted on. So what do we do with that poster now? We keep it, maybe, as a memory of where we started, as a visual fossil of our old misconceptions. But beside it, we place the truth. The sleek, feathered, fast creature that the desert once echoed with. A creature that didn't need to roar. It just needed to look at you and let you know it could. It's shedding season. You find yourself following soft trails through ancient woodland, and at your feet lies a small pile of feathers. Not torn, not bloody, just left behind. A delicate curl of a down a fan-shaped secondary, a stiff tapering primary. All different, all dropped. This isn't violence, it's nature doing what it does, refreshing, recycling, replacing. And just like that, you've stumbled into the forgotten ritual of molting. Modern birds do it all the time. Some slowly losing feathers over weeks or months. Others explosively dropping everything at once like they're walking through an awkward adolescent phase. Chickens can look haunted. Parrots get cranky. Geese hide. But what about dinosaurs? That's where it gets weird. Because while we know dinosaurs had feathers and we know birds molt, there's still a dusty patch of uncertainty over when that molting behavior began. Did Velociraptor shed feathers one by one? Did Microraptor lose tail fans seasonally? Did Eutyrannus walk around half-plucked during Cretaceous summers looking like a disgraced peacock? Historians still debate the timeline of molting in feathered dinosaurs. So far, no fossil has been found mid-molt. No half-bald dino frozen in ash, no pile of shed feathers beside a sleeping theropod. But molting doesn't fossilize easily. Feathers decompose quickly unless buried instantly in the right sediment. The silence isn't evidence of absence, it's evidence of nature's cleanup crew doing its job. Still, we can make educated guesses. Many of the feathered fossils, Anchiornis, Confuciusornis, Sinosauropteryx, are so well preserved that we can see feather layers. In some cases, there's overlapping plumage with different growth stages. That suggests cycles, renewal, a pattern of loss and regrowth, like rings in a tree or scars on a claw. Odd fact, some birds eat their own feathers during molt. It helps with digestion and recycles nutrients. If ancient dinosaurs did the same well, it would explain the lack of discarded fluff in the fossil record. They didn't leave a mess. They ate the mess. Molting isn't just about vanity. It's crucial. Feathers wear out, fray break. Insulation declines. Aerodynamics falter. And for a creature that might rely on feathers signals for courtship defense or even identity, staying sleek isn't optional. It's survival. Picture a caudipteryx in full pre-mating molt. Feathers fluttering off with each movement. Color fading, patches missing. It's vulnerable. Not as fast, not as flashy, but that's the cost of staying sharp long-term. A biological reboot. And just like modern birds, some dinosaurs may have timed their molts for safety, choosing seasons with less predation, fewer mating pressures, more food. There's a darker side too. In some modern birds, molting can cause stress, aggression, even confusion. Hormonal shifts, physical discomfort. It's a delicate balance. Imagine a feathered troodon pacing its territory, half-shorn, moodier than usual. Not exactly the fluffy assassin you want to meet at dusk. Some researchers propose a staggered molt system in early feathered dinosaurs losing feathers in sequence, not all at once. That allows for constant movement, minimal exposure. Others suggest symmetrical molting like birds today, shedding feathers in mirror image patterns so balance isn't compromised. Because if your tail fan keeps you upright in a sprint, you can't afford to shed it all at once. And here's where it gets even more: human feathers sometimes don't grow back right. Modern birds can develop deformed, twisted, or even color-shifted feathers after a bad molt. Nutrient deficiencies, stress injuries, they all play a part. Now imagine spotting a Sinornithosaurus fossil with a single feather growing backward. Was it genetic disease? A botched molt after a long winter? Every weird detail is a new story. Some fossils do hint at this. Asymmetrical feather patterns, ragged edges, discolorations where melanosomes should be consistent. It's not proof, but it's suspicious. Like catching a photo of your cat mid-yawn and realizing it looks absolutely possessed. And then, of course, there's the question of display. What if molting was the display? In some modern species, shedding old feathers reveals brighter ones underneath. Birds go from dull to dazzling in a week. If dinosaurs had similar systems, molting might have been part of the courtship show. Look at me shedding these boring grays. Behold my new crimson shoulder patches, who's ready to mate? You chuckle softly. The idea of a grumpy, molting microraptor grumbling through a prehistoric fashion week is almost too good. But there's also the possibility that molting marked other things' maturity status, even mourning. Some modern birds molt when they lose a mate, others after a successful clutch. Could a dinosaur's feather loss have signaled something more emotional? A rite of passage? A new rank in the pack? Science hasn't found the answer yet. But the more we learn about feathers, the more we understand that they were never just decoration. They were armor, camouflage, thermoregulation, flirtation, and transformation. You pick up one of the loose feathers at your feet. It's black, rimmed in white, likely from an Anchiornis-type creature. Perfectly fossilized, but ghostly light, like it's barely touching this world. And that's molting in a nutshell. A shedding of the old to make room for the new. In life and in evolution, you're here now at the edge of everything. It's quiet. Too quiet. The wind stopped. The trees seem to lean in. The ferns don't rustle. The horizon burns with distant fire, not light, and ash drifts down like feathered snow. You take one last breath before stepping forward into a moment frozen in time. This is the end. Not yours. Theirs. All around you, the world is cracking. The sky is darkening. Somewhere beyond this forest, a rock the size of a mountain has slammed into the sea. Shock waves, heat waves, tidal waves. The age of dinosaurs is ending not with a bang in the forest, but a whimper under falling ash. But not all of them. A rustle draws your eye. Something small darts past, not running, flapping, not panicking, adapting. It's feathered, lean, bright-eyed, it doesn't roar, it chirps. And just like that, you understand. Feathers meant survival. When the asteroid hit, it wasn't size or strength that saved a species. It was adaptability, lightness, warm-blooded metabolism, social behavior, the ability to seek shelter, forage smarter, move faster. And right in the middle of that evolutionary sweet spot stood the feathered ones. The big, scaly predators fell. The armored titans collapsed. But the little ones, the ones with beaks, feathers, and feet that gripped branches instead of clawing earth, they kept going. This wasn't luck. It was legacy. Feathers had started as insulation, then became display, then tools of flight, then symbols of care. And by the time the world turned upside down, they were everything. A way to live, a way to stay warm, a way to glide from burning tree to safer branch, a way to pass on the memory of a world that no longer existed. Historians still debate exactly which species crossed the boundary. Who lived? Who died? Fossils from the layer known as the KPG boundary show both birds and non-avian dinosaurs gasping for space. Some disappeared without a trace. Others left feathers embedded in the rock like ghostly fingerprints. Odd fact, some scientists believe birds with beaks and ground foraging habits had the best survival odds. Flightless birds likely vanished. Specialized ones, too big, too slow, too fussy, also went. But generalists, the scrappy, adaptable ones, they took to the trees, then to the sky, then to the future. You look up. It's morning again. The ash has settled, and in the sky above you, wings beat. But not leathery ones, not bats, not pterosaurs. Birds. They swoop in spirals. They call to each other. They glide with precision their ancestors never knew. And when they land, the ground remembers something ancient, something that never quite left. The feathers remain, not just as relics, but as proof that what began in the underbrush tufts on a tail fluff, under the arms a crest raised in defiance, wasn't just for show. It was the scaffolding of survival. Dinosaurs didn't go extinct. Not all of them. They evolved. They shrank. They changed. They sang. And now they perch on streetlights. They nest under bridges. They watch us with knowing eyes from rooftops and rice paddies and frozen fence posts. They are the survivors, and the proof that feathers weren't a fluke. They were the future. You take one last look at the landscape. Quiet again, but not dead. In the distance, something trills. A call layered in ancient DNA. A whisper of the world that was. You don't need to see it to know what it is. It's a dinosaur, just smaller now, and louder. Feathers were never just about flight. They began in the shadows of time, not as wings, but as warmth, as camouflage, as conversation, as care. From tiny filaments sprouting on early theropods to the iridescent plumage of four-winged gliders, feathers became a signature of adaptation. They helped dinosaurs woo, hide, hunt, and survive. They cushioned nests, regulated heat, and made social signals visible across plains and forests. Even in death, they endured, etched in stone, dusted across fossil beds, whispering truth in the language of barbs and veins. Some dinosaurs flaunted them. Others wrapped their young in the anthologam. A few may have glided. Fewer still learned to fly. And when catastrophe came, it was the feathered, the warm-blooded, the adaptable who slipped through the firelight into tomorrow. They're still here, on your windowsill, in your morning songs, at the edge of forests and the heart of cities. Every pigeon, every hawk, every sparrow is a note from the Mesozoic, sent in feathers and blood. Proof that dinosaurs were not monsters, but marvels, not extinct, but evolved. So next time you see a bird tilt its head or ruffle its feathers in the breeze, remember what it carries: not just flight, but fire. Not just music, but memory. And the long, soft echo of an ancient world that never really disappeared.